Shall we start the meeting? So very good afternoon to one and all. Sorry for the delay since I am fed up with some other work. There is a little delay in it. Very sorry. So as planned, this is the second day of our FDP, and the today's session, afternoon session topic is how to implement artificial neural network with the help of MATLAB software. Since it is the kind of algorithm, one has to know the different steps you have to follow to implement the ANN model. First of all, you need a data set. The data set should be loaded into the environment. As I said in every presentation, the neural network model development involves two stages of development. One is separating the data into training. Another one is for testing. So you have to divide the data accordingly. Followed by that, you should define the network structure. These two components, that is separating the data set into training and testing, and defining the network structure, these two components that we have discussed in the design issues of BPN model in the morning session. So followed by that, you should initialize the values for weights and bias, then initialize the network, then the main part, training the network, followed by testing the network, and at the end, you have to display the results. So these are the steps you have to follow. So here my presentation is followed in such a way that first I will explain the code, MATLAB code, how to develop the ANN model, that is especially backpropagation neural network model for doing a particular task. Then I will give some hands-on, maybe you can call it as a demo, or if you are if you are able, you can open your MATLAB software in your system and you can start writing the code. And then followed by that, I will give some case studies, so that you can use that case studies. After the end of the FDP, you can work out on that case study with the code that I have provided. So the same code can be used for many of the case studies that I have discussed, so that you can have one more hands-on experience on your own with the MATLAB software. In case while doing those case study, if you face any difficulties, then I may be contacted to clear your doubts, or if you face any error, I may clear your errors also. Okay, let me start into the step. The first step, loading the data set. So as usual, whenever I start the MATLAB programming, I used the keyword CLC, that is to clear the command window. Then clear all, it is meant for clearing the workspace. Then close all, it is used to close all sub windows. If any sub windows is, or if any child windows are open, then those windows have been closed. So these are the first two statements. Even close all can also be used as a part of the two statements. The first computational statement is the load command. So load iris data.m. So iris data. So what is this data is? This is a data about a flower belonging to the family of iris. There are three kinds of flower: setosa, virginica, and versicolor. Three kinds of flowers are there belonging to the family iris, and that data is taken from UCI machine learning repository. So if you Google it, UCI machine learning repository, it will take to enormous number of data set. Out of the data set, you can look for a data set which is used for classification task. In that, you can find the data set which is having the name iris. So I take the data. Actually, the data is in the .dat format. Then I open the data in the notepad. As usual, as I explained in the yesterday session, like score data as well as vote data, I created the data, that is I copied the .data file data into the MATLAB environment and saved the data in .file .m extension in the name irisdata.m. So now irisdata.m is the file that contains the data. So using the load command, I loaded the data. So for your understanding, let me explain is with the help of the UCI machine learning repository. So for which I stop the screen, then I will go to one more screen. So here you have to type UCI machine learning repository. In the UCI machine learning repository, you will find a lot of data sets. See, this is the page of UCI machine learning repository. Out of in this, you can find many data sets. See, these are the most popular data sets. They are all some new data sets into the repository. So among the list of data set, which is very widely studied by many of the researchers, the iris data. So if you click this data, it will take you to the location where the data is exactly available. So you can find two folders, data folder as well as data description. If you click this data folder, you can get the data, iris.data, iris.name. So this is the original data. Iris.data is the original data. Iris.name is the one that contains the name of the variables. If you click here, iris name, it will save the data in your local disk. See, it is asking to store that data. Remember, the type of the file that is stored is .dat file. So I stored this data, and then I opened the data in the MATLAB environment. Just to opening the data in Notepad, copy that and pasted it. Let me explain that. See, I copying the data iris.data. It is stored as a data. Let me store it on desktop. So here it is stored. So now I'm opening the data. So just I open the data with simple notepad. So this is the data. This is the data 5.1, 3.5, 1.4.2 iris data. So that means this is the 5.1 is the value for first variable. 3.5 is the value for the second variable. 1.4 is the value for the third variable. 0.2 is the value for the fourth variable. And these four variables are input variable. And this last one is the variable which belongs to the class label. So likewise, you have many data. That is totally how many number of data are available is totally 150 number of data are available. 50 data belongs to Setosa, 50 data belong to versicolor, and 50 data belong to Virginica. So Setosa, versicolor, and Virginica are three different kinds of flower belonging to the family iris. So likewise, if you go, you can download the name, download the iris name file. So that also I can open it with the help of notepad. So here I think these two screens are not visible to you. Let me stop it, and again once again I will make you to understand that idea also. So this is iris data, value 5.4, 3.7, 1.5, 0.2 belongs to the class. These are variables value, and likewise you have all the categories Virginica, versicolor, and etc. All three kinds of flowers. And if you go with variables, here you can find, see, this is the variable names, source details about the data set is given. Here you can find the attribute information, sepal length information, sepal width, petal length, petal width. So all the four are input variables that are represented in centimeter. and finally classes iris setosa, iris versicolor, iris virginica. So what do you infer from this particular file? So you downloaded the data from UCI machine learning repository. What is the data you are downloaded? That is iris data. So while you are going to download the data, you have to locate the correct file. Once you have opened the data, just you go through the data and study how many input variables are there and what are the associated classes. So after that, what I did is just I copied the data. So just I copied this data. 5.4 is meant for sepal length, 3.6 is meant for sepal width. This 1.4 is for petal length, 0.2 is for petal width. This is for class label. Likewise for all the categories. I just copied the data and pasted in the MATLAB environment. After that, I have to do little what is that? Little pre-processing in the data. So this is basic pre-processing which doesn't need any computation. That is, I don't need comma, so I have to remove the comma first. And I want to designate iris setosa in such a way that it has to be understood by the ANN model. Likewise, I have to modify the data. So in what way I have modified the raw data that I will show you in the MATLAB screen, for which I stop this screen share and I will go to the another screen. So our MATLAB screen. So I already created the file. See here. So this is our data file. This is the data file. This is the data file. So the complete data is there. So where the data starts, here it starts 6.3, 3.6, 6.2.5 to 6.2.5. The data has been rearranged. That's why the first record that is shown there is not available here. So see these three are class labels. 100 corresponds to iris setosa. Likewise 010 corresponds to iris versicolor. Likewise 001 corresponds to virginica. So this is the way the output has to be represented. This idea is similar to the idea of softmax in the deep learning neural network. So that's the idea here. That is, your neuron will always return class conditional probabilities, and that class conditional probabilities could be changed accordingly to represent in the form of zeros and ones. So this is the way we have to prepare the data. So this data only we are going to take it for neural network model development. So why before going into develop the model, you need to understand the data. So what are the basic information you need to understand from the data? How many number of input variables are there? So how many number of input variables are there in the data? There are 4 input information. Iris sepal length, sepal width, petal length, petal width. And what is the output label? Output variable is 1. And how many values for the output label? 3 values. Setosa, virginica, versicolor. They are all represented numerically in the form 100, 010, and 1001. So likewise, it is represented. So this is the way you have to prepare the data. And for this data only, we are going to develop the model. So now look at the data. So I told you that there are 150 records. Likewise, there are 150 records. If you still want, I can remove this command line. So how many data are there? See, totally 150. What is the last record? Totally 150 records are there. For each category, that is for iris setosa, 50 records are there. Virginica, 50 records are there, and versicolor, 50 records are there. So totally put together, 150 data is available. So this data, you have to load it into the environment. So once the data is loaded into the environment, as I said in the yesterday class, with the help of score data as well as vote data, once you loaded the data into the environment, it is stored as a matrix. So if you load this iris data, what is the size of the matrix? What is the size of the matrix when this data is loaded into the environment? Yes, totally 150 records are there. So totally how many number of rows? 150 rows. How many columns are there? 4 columns for input variable and 3 columns for output variable. So totally how many columns are there? 7 columns are there. if you are clearly watching this exercise, if you have any note and pen, make a note of it. The total size of the data matrix is 150 cross 7. So then only it is easier for you to follow the rest of the lecture. So the input data is iris data whose matrix size is 150 cross 7. 150 is number of records, that is number of rows. 7 is number of output, number of variables, that is number of columns, out of which the first 4 columns correspond to input variable, the last 3 column corresponds to output variable. But you don't think so. Since there are 3 columns are allotted for output variable, there are 3 output variable. You don't think so. There is only one output variable, but each output variable is designated by suitable representation. So you have 3 columns. So if you are following the lecture, please take a note and note it down. The total size of the data is 150 cross 7. So now I stop this screen share and I'll go to the presentation. So the iris data is loaded with the help of the command load. Now this iris data is assigned to the variable xy. Now what is xy? Remember the yesterday class, xy is a matrix which has assigned the iris data. So what is the size of xy? It is 50 cross 7. So from this, what we are doing is, first we are dividing the matrix 150 cross 7 into input variables and output variable. So xy is the variable which contains the whole data, which that includes both input and output. From xy, we are creating the variable x as well as the variable y. You know the matrix operation that I discussed. So from the matrix xy, I need all rows. So I use the colon, comma. What are the columns I need to get only the input? First 4 columns. That's why I mentioned 1:4. Then come to the second variable y. Y equal to, from the matrix xy, I need all rows. That's why I mentioned a colon, comma. What are the things that is required? Thank you. What are the things that is required? 5 comma 6 comma 7. That is 5 to 7. That 3 columns are output columns. So this is the way that I have to separate the given data matrix into a matrix containing only input variables and a matrix containing output variables. So this is the first step of developing the ANN model through MATLAB code. Second step. The second step is separation, data separation, followed by the third step, data normalization. So what is data separation? So it is nothing but dividing the data into training and testing. So for which you can follow any strategy for dividing the data into training and testing. Here, if you need any clarification, please note down the question. I will answer at the end of the presentation. Participant, if you have any doubts or any clarification, please note it down. I will answer the question at the end of the session. So here the task is to divide the data into two. One is training, another one is testing. So for training, the data is separated. In the form of 50:50. That is 1:1 ratio. I already told there are many ways of dividing the training data. One possible way is dividing the data into 25% for testing and 75% for training. And another way is 40% into 60%. Here what is done is 150 data is there. So 75 data is utilized for training and 75 data is utilized for testing. This is what the command that is used for dividing the data into training and testing. Both the input as well as the output are trained. See the command x2 is a new matrix that is equal to, it is to be created from the matrix x within bracket 1:2:150. So in the row side, we are giving 1:2:150. That is 1:2:150. That means I need a record from row 1 to row 150. But I didn't need all the 150 rows. Instead, I need 2 rows once. That means first row I have to take and Then I left the second row, then third row is taken, then I have to left the fourth row, then fifth row is taken, then I have to left the sixth row, then seventh row. So 2 rows once I have to take the data, and that data is assigned into x2 variable. Likewise, y2 also. So now what is the size of x2? Because in the column I have used comma colon, that means all columns. What is the size of x? The size of x is 150 cross 4, from which 50% of the data has been taken with the command x of 1:2:150 comma colon. Now what is the size of x2? 75 cross 4. What is the size of y2? 75 cross 3, because it is taken from the output here y. Now the corresponding locations of x and y are made 0, and then the x and y is assigned to x1, y1. So in this condition, the third command x of 1:2:150, that is equal to empty matrix, empty square bracket. This means that whatever the location that we have taken the data to assign into x2 and y2, those locations are filled with null values. Once the null values are filled, now what is the size of x and y? X is remaining 75 cross 4, y is remaining 75 cross 4, 75 cross 3. This remaining 75 cross 4 is assigned to variable x1, as well as remaining 75 cross 3 is assigned to variable y1. Now, what are the 4 variables you have? X2, y2, x1 and y1. 4 variables are having. In this 4 kind of variable, x2 and y2 are variables that are going to be used for testing. X1 and y1 are 2 variables that are going to be used for training. So what is the size of x1? What is x1 first? It is training input data whose matrix size is 175 cross 4. What is y1? It is training output whose matrix size is 75 cross 3. What is x2? It is testing input whose matrix size is 75 cross 4. What is y2? It is testing output whose matrix size is 75 cross 3. So in that way, you have to divide the data into 2 categories. One is training and testing. Inside the training, you have training input, training output. Inside the testing, you have testing input and testing output. Since we followed 1:1 ratio of dividing the data, so we have 75 data for training as well as 75 data for testing. So followed by data separation, the most important task in terms of the ANN model development is normalization. So this normalization is a task which keeps any variable value whose value is beyond the scope of the limit is brought to a minimum limit, or brought to a predefined limit, or within 0 to 1. So why this normalization is conducted is because when you are going to work with variable, say for example, if this data is contained only 4 variables, sepal length, petal width, sepal width. If you look at the ranges of these variables, all variables ranges are maybe around 4 to 8, or 5 to 7, or 1 to 7, or 2 to 4, like that. So all variables ranges are within 10. So no need to normalization here. However, I used normalization to illustrate for some large scale problems. Say for example, I am going to explain some case study later after this presentation. Those problems, the data set have data variables whose values are in the range of 1000, 2000, even some lakhs are also there. So when you are going to use a data which contains 4 variables, one variable range is in the range 2 to 5, another variable range is in the range 20 to 50, another variable range is the range 30,000 to 40,000. That means one variable is lower valued variable, another variable is higher valued variable. If these two different varieties of variables are used as input to the ANN model, what has happened is the ANN will stuck into bias by focusing only on the higher valued variable. That means the higher valued variable will begin to dominate the lower valued variable. That means we need uniformity in the variable values. So in doing so, we need to go for normalization. So normalization is carried out here. So this normalization is min-max normalization, and this expression you can find it very well If you Google it, or you can use any pattern recognition book, or you can refer a data mining book by Han and Hamber. This formula is given. This is nothing but min-max normalization. So this formula has been implemented here for each variable. Each variable. I think it is easy once you code it on your own to understand what is exactly going on. So followed by data normalization, then what you have to do is creating the network. So creating the network involves creating the structure. So since this is a backpropagation neural network, there is only one hidden layer is followed, and we have to say how many number of hidden nodes in the single hidden layer. So nhid is a variable that is used to designate how many neurons in the hidden layer. So there are 4 neurons in the hidden layer. What is the number? What are the neurons in the output layer? 3 neurons in the output layer. So PR is nothing but what is the minimum value of the total data set? What is the maximum value of the total? So that matrix is assigned here. Why this PR is required is that the next command, that is the 4th command, we are using a command called new FF. That means new feed forward neural network. That is, this is the command. New FF is the command that is used to create a new feed forward neural network. So if you use MATLAB software, if you type help new FF, then you will get the help for this command. That is, what are the arguments that you have to pass? You have to pass the arguments that are required. So this is PR, that is the minimum and maximum value of the entire data, number of hidden neurons, number of output neurons. So transfer function as well as output function followed in the hidden layer, and the training function and the learning function as well as the square ordered function followed, all are mentioned inside the new FF function. So this step is going to be called as creating the network, initializing the structure of the network. Then we have to initialize the weights and bias randomly. So for which first you have to generate the random number generator. So then with the help of this inbuilt function, this is net.layers1, net.input layer, input weights are one. This guys inbuilt statements, you need to initialize the layer. You need to initialize the weights in each layer as well as bias in each layer by means of some random commands. So these 4 statements, net.layers, net.input weights, net.bias, and net.biases, will initialize the bias as well as weights as well as the layers. Once you have done, then you have to initialize the network using the command init. So init is the command which is used to initialize the network. So all these set of statements are going to be called the statement that is used to create the network. Then followed by you need to provide a set of statements for training. So to start the training, first you need to mention the number of epochs. How many iteration I need to train the network? So I have initialized 1200 epochs for this exercise. And how many? What is the goal? Goal is nothing but acceptable error between the network output and the target. This is point not one. So then I use the command train. Train is the inbuilt command available, which is used to train the network. So inside the command, inside the command train, you need to give the net, comma. See here, x1n, y1n. What is x1n? Training input normalized. N stands for normalized value. Y1n, training output normalized value. So during the training of the network has to be trained with the help of input variables as well as the corresponding output variable. So when you train the network is returned, the trained network is returned in the net variable, and the trained parameters are returned in the TR variable. So train is the input function, or otherwise say that it is a function which accepts 3 parameters, net, x1n dash, y1n dash, and it returns 2 values, net and TR. So net is the trained network and TR is the performance parameter. So from the net performance parameter, you take the important parameter, that is mean square training error taken. So here it is used a command to read the CPU time. Why it is used this here is we need to calculate how many number of time CPU time it is taken for running the total network. So this command is used. So here the net bias, net weight value as well as bias values are updated with the help of the corresponding command net.iw, net.b, and net.lw and net.b. So it is updated based on the training performance and based on the training during the error, based on the error value during the training. So this is all about network training. Followed by network training, you need to go into testing. For testing, you need to use the command sim. Sim is the command that is used to simulate the network, that is, test the network. See, look at the command carefully. Sim is a inbuilt function which accepts only two parameters, net comma x to n. Whereas if you take the case of train, it accepts three parameters, net, x1, y1. So while training the network, you need two things, both the training input as well as training output. Whereas while testing, you need only training input. So the trained network is given, that is net, it is a trained network. Then the trained network is provided with only the unknown input. For the unknown input, small y is created. That small y is nothing but network output. So the network output is used to calculate the difference between the actual output, that is a target y to n, to find the error. From the error, mean square testing error has been found out. Then some suitable arrangements have to be carried out. I will explain the code here. Suitable arrangements have to be carried out to make how much data that is simulated to be a particular class and how much data that is actually present. Based on that, you have to initialize a counter, that is C. S of I designates simulated input counter. A of I is nothing but actual output counter. So based on these two, we need a counter variable CC, which is used to convey how many data have been classified correctly. I explained this portion during the program. After this has been done, you need to plot the performance of the ANN model with respect to BO, that is network output, against RX, that is actual output. Sorry, network output is actual output. So you need to plot a graph. From the plotting, you need to conclude many things, and you can say what is the performance of the model and what are the limitations of the model, in what way you can expand it further. Likewise you can discuss many things with the idea. So these are about the code development for ANN with respect to sample data. So I will explain the MATLAB software with the help of the code. So now the MATLAB screen is visible. I hope the MATLAB screen is visible. Is it?
Yes, sir.
MATLAB screen is visible, sir?
Yes.
Okay. So I will proceed. So I just now I told that this is data. Now I will open the program. I have program here. So this is Iris program. So what are the data I explained? See, this is the first three statement I explained. That what is this three statement is about? This three statement is about some preliminary step before writing the program. CLC, clear the console, clear the command window, clear all, clear the workspace window, close all, close any sub windows are available. So these are the first three preliminary statement one has to write for better clarity of the program before writing the main code. So load the iris data, this you know very well. So second is XY iris data. So input is separated, output is separated, testing data is separated, and training data is separated. So here what normalization is carried out for X1 and normalization is carried out for Y1. Now need to do normalization just as it, because it is contained only ones and zeros. So in this for this particular data, no need to go for normalization because already the values are very minimum. But even then, it is better, good practice to go for So here, why this command T1 is here? So this is the area you have to start the network training. So before that, you need to get the CPU time to calculate how much time the network is taken, so that I can calculate the overall time consumed by the network model for understanding this data, for which I used a variable T1. With the help of the variable, I assumed I assigned the CPU time, that is from the software, using the MATLAB software. So these are the statement that I explained all these. On this here, P.R is one variable, N head, N out, new FF. See, if you open new FF, if you go for help on new FF, you will get into the meaning of the new FF. So new FF create a feed forward neural network. So this is the latest version, that is I am using a 2019 A version, but this version new FF is a method that is obsoleted in the 2010 itself. Even then we can use it, no problem in it. So it is accepting these many parameters. We have used those parameters inside the NeoFF. For better understanding, you can go through it on your own, then after in your free time. So what is the parameter and what is each parameter is about? How can I change the value of this each parameter? You can change it. You can run this program again and again for better understanding and better clarity. Here there is another as under train. So this method, if you open and help on train, it will give you. So this function trains a shallow neural net. See the name, shallow. See the name. See the name, shallow neural network. Someone is talking in the middle. So something is train is there. So train is the function used to train the model. So in which you have 3 parameters. Likewise, there is one more parameter, that is sim. Sim is the one which is used to test the network. So here comes the main picture. See, yesterday also one ma'am is asking that doubt. So how to take the output of the neuron with respect to 0 and 1. So let me run the program one by one. Then I will come to the last part. So first I will run this particular portion. Load the data. So for understanding, I will comment the rest of the lines. First, I will execute the first 2 lines, that is loading the data. And so look at the workspace window. So no variable is there. The workspace window is very clear. So now I am going to run the program which contains only 2 statements. Load iris data, xy equal to iris data. See, iris data is loaded. What is the size of the iris data? 150x7. So that iris data is loaded and it is assigned to variable xy. So what is xy? It is the data that contains the value, all the values, 150x7. So the data, then you have to divide the data into testing into input and output. Excuse me, sir, someone is interrupting the lecture. Could you please mute all the participants?
Sir, actually you are the host. Can you kindly mute all the participants, sir? Actually you are the host now.
Yes. Yes, I muted all the participants. So then after loading the data, you have to divide the data into input and output. So now I uncommented the another 2 line. Let me check the output here. See, look at the workspace window. You have the iris data as well as the XY matrix. Now after uncommenting these another 2 line, these 2 line is about dividing the input and the output. While I am executing it, see, I have another variable x and y. 150 cross 4, 150 cross 3. I hope a few of the participants are following my lecture by taking a matrix size. In the initial presentation, I told take a note and make a note of the matrix size. So I think few of the participants may follow in the matrix. See, the same thing is here. 150 cross 4 is for X and 150 cross 3 is for Y. Now, 75 data is used for testing. Next two lines are, I am uncommenting it. I am running it. See, what is X2? 75 cross 4 and 75 cross 3. X2 is meant for testing input and Y2 is meant for testing output. Then another two lines. The two lines. So when I running the line, see X1, Y1. X1, what is X1? This is 75 cross 4 double, and Y1 is also 75 cross 3 double. So you can also open this. See, if I open this, I can see the values. See, I can see the values. You can see the values. So likewise, you can also do it. So now we are doing the normalization. So I uncommented all this thing. So input and output are normalized. After normalization, you look at the difference. I am running this bunch of codes. So now I got X1 is this unnormalized training input. This is normalized training input. By the name of the variable itself, it is differentiated. X1 is input variable for training. X1n is normalized input variable for training. So I will open this matrix. This is X1. See the value. It is actual value. See the X1n. So this is the value that is mapped between 0 and 1. So this value 5.8 is mapped to 0 to 1, and we got 0.4. So likewise, all the variables are mapped between 0 and 1. That is called the task of normalization. Now the network is trained. See here, the new neural network has been defined. So until now, then I uncommented the line. Network training. So network training is given to some components. So network is trained using new feed-forward neural network. So I am running the code. See, now network is created. Network is created. NHID 4, NHID 3, minimum value and maximum value. The CPU time is 90.828 seconds at that time. So this is just to take the value to estimate the whole execution program. See, this is the neural network. How many dimensions, how many connections, suboptions, everything is 0. Why it is 0? Because we have just created the network. That is not created the network. We have just declared the network. So we have not initialized other values like weights and biases. So those values are not visible here. So you can view it even further with the help of something. With the help of taking the value from the command prompt. So if you are interested, I will take this in some other sessions. So this you can unblock it. That is meant for training. So this portion is meant for training because a training is command is used. So if I execute here, training is conducted. See the screen, training is conducted.
Sir, please share the screen.
Pardon?
Please share the screen. Screen is not visible, sir.
Screen is not visible.
Sir.
Now it's okay.
Okay, sir. Okay, sir.
So now once again, I am going to tune into it. So this portion is meant for training. I am once again executing the portion. So network is trained. See, the screen is appeared. So this portion is the one which is visualizing the network training. Look at the figure. So we have 4 input nodes and we have 4 nodes in the hidden layer and 3 nodes in the output layer. So this is the architecture of our neural network. So we have used the scaled conjugate gradient method for training. That is the backpropagation model. And the performance measure we have used is mean squared error. So the epochs, we have maximum epochs 1200 epochs, and until 482 epochs we have reached the goal. So what is the goal we have set? we have set performance. The goal is here, performance. 0.01 is the goal. See, the goal has crossed 0.09. So the gradient values are displayed here. You can take the values. So you can visualize the performance by clicking that corresponding button. So this is the performance curve. This is the training state curve, and this is the accretion curve. Accordingly, while you are writing paper, you can infer the results, and you can write for whatever the screen that is displayed for the data that you have executed for your data case. So then here something is conducted, that is testing using the command sim. So now once again I'm executing the program. See the network after training. So network will have some values. Okay. Since this latest version doesn't show any value, actually the oldest version will show some value. Yes, TR. TRC. This is the trained network. It has all the values. TR. After training, the training performance. What is the training function? What are the training parameters? And what are the things? Everything is here. You can take whatever the values you need. So weight parameters is also there. If you want to take the what is the weight value that is obtained, you can use the gradient. See, this is the weight value. This is the weight value. So likewise, you can do all the things, and you can understand all the facts. So now I am going to simulate the network. So now with the help of sim command, the network is simulated. So once simulated, you will get that error value E. See, this is the error value. For this first row is for Setosa, and this second row is for Virginica, and this third row is for versicolor. See, all these values are not zeros and ones. It is just a conditional probabilities value. That means it is the value between 0 and 1. 0 and 1. Now we have to take these value to calculate the mean squared error value. Then see, using this value y. So let me show you the value of y here. So where is y here? Where is y? Yeah, this is here. Y is there. So this is the probabilistic value for the first case, for the second case, as well as for the third class labels. So this value is usually in the range 0 to 1. Here you have to use. Here you have to use some kind of threshold value so that the value will be either 0 or 1, because we designed our network like that. 100 means first class, 010 means second class, 001 means third class. So you need to apply some kind of value, threshold value, to make the value either 0 or 1. So this is a different kind of topic that you need to understand from the probabilistic classifier model. So for which here it is done. I am commenting it. So before executing this particular portion, what is the value of y? This is the value of y. This is the value of y. Now after executing, see what is 0.9825. What is the command I have used? If that y of ij is greater than 0.5, it should be 1. Otherwise, it should be 0. So once again opening that, see here anything is between something the value. So all are greater than value. So it is something is 1. So now I am executing this portion. So once you executed this portion, now you got again the y value. See that y value has gone 100. That means 100, that belongs to one category. 100. Likewise, totally first 25 is there, and the rest is 25 is for second floor. See 011 and 100 is there. 0001 is for there for third category. That is up to 75. So since there are 75 cases are there. Once it is taken, now the output variable is also designated like this. So now I explain you what is S and what is A. So you have two matrix, Y2 matrix and Y matrix. So what is Y2 matrix? Let me take the Y2 matrix, or Y2N matrix. Y2N matrix is the target. It is available like this, 1000000 like that. Now what is Y matrix? It is in the form. So you can take the transpose. So I want to take a transpose. I want to compare Y2N with Y. If it is closer, then I have to make one data class classified. Otherwise, I do not take that data and I left the data as unclassified data. So to make it simplified, I have converted the small y into 1, 2, 3 to signify class 1, class 2 and class 3 as in the variable s, since it is simulated. Likewise, for the variable y2, I converted the value of 100 into 1, 010 into 2, 001 into 3 and is assigned in the variable a. So now after executing this particular portion, you may get yes, see 11111 for the first 25 cases, 2222. That if there is misclassification, you didn't access. See, in the data 41, it is actually second class, but it is showing first class. Likewise, you can find it out the difference. What is the actual case? Where is the variable a? Yeah. Here is the variable a. So this is the variable a. So why these states say until the code 75? See, not 75. This until this line 72 line number 72, our simulation ends. But what for these lines are? These lines are meant for making the number of data that is currently classified and also giving a plot. In what way we have to give the plot? So this is the way in which we have do S and A. Then this S and A is used for a comparison to make the count. So I am uncommenting the data. So I have S and I have A, and whenever S and A are equal, CC is incremented. So totally, how many S is there? 75 values are there in S and 75 values are there in A. So just I need to do a comparison operator for the different S value with the different Y A values, and accordingly the counter variable is incremented. Then the final CC value is displayed. See, what is the CC value? Yeah, CC is here. So the value of CC is 73. What it means? So I took 75 data for testing. Out of the data 75, 73 data have been successfully classified. So what is the performance? 73 divided by 75 into 100. That is the performance. So finally, I need to do some graph. So this graph is some kind of graph that is not available in, because these are the code that we have developed in the very older version of the software. There is no facility for automatic drawing of graph. So you need to draw a graph on your own by taking the value from the workspace. So here S is the value that shows the simulated output, that is network output. A is the variable that shows the actual output, that is the target. For both the thing, we are plotting the graph. So yesterday I have told you how to plot the graph. The same command is used here. So once again, I am executing the program to get this kind of output. See, first class, there are two data that is not classified, that is maybe misclassified. So second case and third case. Here there are two different symbol. Cross symbol that signifies output, the actual output, and O symbol that signifies the network output. If two overlaps are there, then that data is said to be classified. Otherwise, the data is not classified. So here there are two misclassification. The two misclassification is predicted. That is, I think that the data from the second category and two data from the second category, that is 41th data, as well as it is, what is the data, 48th data. Yes, 41th data and 48th data, it is actually class 2, but it is said that it is class 1. This is the two misclassification in this particular data for our ANN model. I hope you understand the idea here, how to develop the ANN model. So that's what, so whenever you have different kind of data, you can use those data, and just you use this kind of statements, the first few lines of statement, modify it accordingly, and then you can do it on your own. So this is the way you can develop the model. Here you can get the output. In the output screen also you can find, see what is the mean square training error, 0.0098. Training time, so during the training, how much time it is taken? 2.14 seconds, and 0.06 is the second taken for the testing. So totally how many data classified? 73 data has been classified. So how to take the accuracy? 73 divided by 75 into 100. Into 100. If you put, then you got the percentage. 97.33 is the percentage of the model for the iris data. So this is the way you can develop code for the iris for the back propagation neural network model. There are other ways also. Nowadays, the recent MATLAB software. See, I am using the latest version only, 2019 version. For your FDP only, I just now installed it. Otherwise, I am working with the previous version only. Anyhow, I also want to study further in the concept of CNN and RNN. So hope it will be more better used for understanding those higher end models. If you want to do these kind of codings, no need to worry about it. Nowadays, the latest software will be allowing apps which will generate the code for you. The same code we will generate it through toolbox, for which you can go app and you will go the neural network pattern recognition tool. Some screen is available here. So here you need to click next. So you can check if you have your own data, you can feed the data here. See, you store the data somewhere in your computer and you store the data in input and output form. So input you store it here, output you store it here, and then you proceed next to load the training process. Here I am using this data. See, when you want to check with the example data, just click load example data. So I choose the iris flower data. See, the data information is given here. 4 input variables. Other things are explained very well here. So then this data is imported. Then by clicking next. So totally 70, 104 sample is, this is by default, 104 sample is for needed for training, and remaining is used for testing and validation. So in the program that I discussed, no validation is performed. So for validation, you have to write separate code. But here, the latest version of MATLAB software has all the packages. So validation is also automatically done. So here you can change the number of neurons. So it is given again. So I need only 2 hidden neurons. So accordingly, here also it is changing. So just click next. So here is the button for training. So training has been done. So this is the curve. This is not the curve that is obtained through program. So this is the curve through the window. So maximum epoch 1000 is set, and with the 26 iteration, so the program have come to an end. This is from this. These are the various graph that you can see for the models. So from the graph you can understand and you can write the inference what you have got. See, this is the confusion matrix. True, positive, true, negative. Also, this is the ROC curve. So everything has been given in the latest version of the MATLAB software. Only thing, you need to observe the output and you need to study the output and you need to give proper inference to the output while writing the research papers. So after that, in addition to that, you need to create your data in such a way that your toolbox will accept the data. So that's the way you need to do it. So this is the way. See, if you click next, and if you want to load import data, you can do, or you can see the MATLAB function matrix only. See, so your old version of the MATLAB doesn't give this facility. Here you can generate the code. So the code is automatic. See, the code is generated. Here you can write on your own to write something or modify something for your own problem. So this is my code for the ANN program for classification of iris data. This can be used for any data set. So this is the MATLAB generated data. That is, you have to study line by line and you need to change accordingly for your case, because this is the code generated by the toolbox for the example data set. So you can change it for your case. So this is the way in which pattern recognition task, that is simple classification task, can be conducted. There is one more tool, neural net fitting. So yesterday someone was asking, sir, my task is kind of task called prediction. That is, my output variable is not a class label. My output label is a real value. For what model I can go for? So you can use the same feed for. You can use the same feed for a neural network model. You can use the same neural network model, but you need to have little difference. The same thing. So the data sets are, these are the data sets. So I use the body weight model. It is estimate the weight of the body. So this is the input variable age. These are the input variables. Just click import it to next, and click train. The training is conducted. And if you want to code for this, you can take the code here. See the code here. So this is the way you can run the fitting toolbox. There is one more toolbox, that is neural network clustering and neural network time series data analysis. That is a kind of dynamic neural network, or you can go with a deep learning toolbox also. There are deep learning toolbox are also available. That is we will discuss in the tomorrow class. So neural recognition pattern clustering tool, neural clustering tool. That is, I said that. So this tool you can use it for. So morning, one participant asked the question about SOAM. If you want to study further about the SOAM, you can use this model. Use to this toolbox. You can load the XSC. Same iris data is explained here. So you can use this model for understanding the SOAM model. It will generate some code at the end. You can use that code for the further development of your model. You can give a try. See, this is the code that is developed for the model. So what is the output of this particular code can be of, I think, not. So since the data is more than 1 element, is not able to plot. Histogram plot. This is the histogram plot, regression graph. Everything has been plotted here. So this is the way you can use the toolbox. You can sub the MATLAB software. This is the regression curve for SOAM model, self-organizing map model for the iris data. So you can use the toolbox. And one more thing, inside the toolbox, you can find a lot of commands. You can study these commands and you can write a program on your own. So I think with this, the today's session about software development using MATLAB software, I explained you reasonably to make you to understand. You can take this as a further step for your problem. Anyhow, I will be giving some case studies. First of all, I will stop this screen. Then I will go into the screen of the presentation. That will discuss about some kind of case studies. So the case studies that dealt with, the first case study is how to use this program, artificial neural network, for detecting the intrusions. So this is one flow chart. You need to collect the data. So actually for this simulation, KDD Cup 99 data is taken. So data pre-processing, data representation, ones and zero, representing the input and output accordingly for the numerical as well as for categorical value. Label as well as the categorical value, normalization, selection of network structure, training, and the attack classes are, there are how many classes? 4 attack classes and 1 normal classes. Normal, denial of service, probe, U2R and R12. So these are the classes used to categorize the intrusion activity of the user. So the data set is downloaded from the website, KDD challenge website, knowledge discovery in data mining, KDD Cup 99 data set. So there you can find the enormous number of data. So out of that, how many number of samples have been taken? See here, 12,723 sample taken. For training 6,000, for the testing 6,000 is used. So the class-wise distribution samples are displayed. So the output is represented like this. 4 nodes are there. Each 0 represent normal. 1 in corresponding node will represent the corresponding. So this is the duty that you have to do, and this duty is discussed as a softmax function in the deep learning neural network model. So this is the parameter setting. So totally 41 input variables are there in the data. So 41 input nodes, 4 output nodes, a single hidden layer, number of hidden nodes 10, goal, number of epochs, activation function the hidden layer, activation function the output layer. So the result, training error, testing error, how many time? 257 seconds, and testing at 0.004 seconds, and how many data have been classified. Individually class wise, so 2,500 data has been taken for normal. So out of which 2,494 data has been classified. So likewise for each class, also for the overall classification, totally 6,360 data has been taken for training, Out of that, 6038 data has been classified correctly. So this is the way you have to report your result for the ANN model development for any of your problem that dealt with classification. So next, another model that is this is also our research in the year 2000, I think 7. Yes, 7. So we developed the ANN model, individual model, that is BPN model in one side and SO model in another side. So we combined the two models. First, we collected the data. When you compare the flowchart of the previous work with this flowchart, so data collection, data represented, pre-processing, everything is same. After data normalization, what is done? So self-organizing map, that is SO model, is used to do clustering tasks. After clustering, only the important code book values have been taken, and it is fed to the backpropagation neural network model. So there is a two different model, that is a hybrid model. So what is the specialty of this model is, instead of using a very big data, so the data is clustered, that is the data is reduced, some kind of dimension is reduced through clustering, and then the process is carried out in a normal way. So in doing so, what you have achieved is, you can identify the important variables, you can remove the irrelevant variables, and you can obtain the output in a faster manner. Radial basis function network for web page classification. So this is one case study how to do classification of web pages using radial basis function network. So the data set that is taken from WebKB data set, it is, you can Google it and you can download sample web pages. And we have selected web pages for some categories. Actually, how many number of web pages are there? Let me explain it in the next slide. See, there are about 8,300 documents in 7 categories. What are the 7 categories? Department, student, project, course, staff, faculty, and others. For each category, how many number of web pages have been taken? 50 web pages have been taken. See, this is the sample web page. This is the sample source code of that web page. So what we have done is, we have taken the, we have applied the some kind of pre-processing with respect to natural language process. That is, we applied a Porter stemming algorithm which removes the tags, symbols, and identify the stem word. Then the stem word is appropriately coded using numbers. After numerical encoding, that is when the stem word, that is the word categorical value, has been coded using numbers, then that coded word is used as a, then that coded word is used for numerical encoding to change it into numbers, then it is fed into RBFN. So then the result has been taken with respect to classification rate. So this is the one example that's discussed about the web page classification with respect to radial basis function network. So pre-processing, some kind of words have been taken from the website. It's stem words. The numerical encoding has been conducted. Totally 7 input nodes have been taken. Input node 7, output node 7, because the same input has to be produced in the output. So this is the model parameter for which we have got the output. So total number of output is 238. So the way you need to display the result. Face recognition. If you do face recognition, you can either use the sample data or benchmark data available in the website, or you can generate data on your own. Of course, this is data generated during my master degree course by one of my colleague. So while doing face recognition, you have to reduce the data and you have to localize the data. The portion what you need is to be taken. Then this portion is to be changed into a vector form. In the shallow neural network model, if you want to do such kind of face recognition, you need to localize the pattern. That is, you need to do all the pre-processing stuff, feature extraction, age detection, localization, enhancement, and the entire localized image, final localized image is taken, and it is vectored, and it is converted into a vector form. And for each image, how many vector variables are available, accordingly the number of input variables have been assigned, and then the processing is carried out like our normal data. But this scenario is not with deep learning neural network, because this simulation is carried out before the deep learning neural network came into picture. So that's the idea that I am giving. No, it is not needed to try this with the ANN model. Better you try this with the deep learning neural network model. So with this, I close the session. If you have any query, I am here to answer your queries. You can raise your hands. If you have any question, you can raise your hands. I can answer your question. Yes, ma'am. Tell me, ma'am, what is the what is the question you have? Punita, ma'am.
Hello, sir.
Yes, ma'am. Tell me, what is the
Sir,
what is your question?
for Python programs and all, we are no need to download the software. Through cloud, we can do the program, sir. Just
Yes,
like
ma'am.
that, do we have a MATLAB cloud, sir?
Yeah, yes,
Uh,
ma'am. Yes, ma'am. MATLAB
In the
cloud is
cloud
also
itself,
there.
we can perform this neural network, everything and all.
Everything and all, everything and all perform. No need to go for the software. You can use the software in the cloud mode. No need.
Okay,
Yeah.
sir. Okay, sir.
So if you want to personalize the software, you can get the software. You can install the software. Otherwise, you can go for Google version. It is available. But compared with R, compared with Python, MATLAB is costlier, and you need license. You need license. That is the
Yes.
problem. That is the problem.
Thank you, sir.
Thank you, ma'am. Is there anyone?
Sir, excuse me, sir.
Yes, Vinod, Dr. Vinod.
Sir.
Shall we close the session, or
Any other questions from the participants?
Yes, ma'am. Tell me, ma'am. Punita, ma'am, again. Tell
Ma'am,
me.
sir,
Sir,
Punita
one
madam
more-
is asking.
one more question, sir.
Yes, ma'am. Tell me, ma'am.
Sir, actually, you are telling
Yes, ma'am. Tell me.
sir, you are telling about the hybrid network now, sir.
Yes, ma'am.
Why do we need for hybrid network, sir? Normally, in which application we are using this hybrid network?
Ma'am, it is not necessary to think about application. It is necessary to think about the problem with the data.
Okay,
So
sir.
what is the problem with the data is, I explained a ANN program for a iris data. So
Yes,
what is
sir.
the size of the data? It is 150 records.
Okay, sir.
Number of column is only 4 variables and 1 output variable. But
Yes, sir.
when I use the same ANN code for intrusion detection, then the number of input variable is 41 input variable. Imagine, from 4 input variable, I am enhancing my program capability to 41 input variables. Likewise, in the small sample, in the benchmark iris data, only 3 output variables are there. But whereas in the case of intrusion, there are 5 output classes: normal, DOS. So my data complexity is little increased when compared with the benchmark data. So in such a case, I need some other alternate algorithm or some other novel idea, so that my performance have been still improved, either in terms of accuracy, or in terms of training error, or in terms of false positive or false negative, or in terms of time. So these are all the performance parameters. So when you develop any code for your data, and if you are not satisfied with the performance parameter, and if you want to still increase the performance parameter, then you always look for some kind of other algorithm, or you can think about joining 2 or more algorithms based on the requirement. So that's why in the second model, we hybridized 2 neural network model. One model reduces the data, another model will do the classification task. So that's the idea. I hope I answered your question.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you so much.
Yes, ma'am. Yes, sir. Segar, sir, tell me. Sir, Segar, sir, ask your question. Hello. Hello.
I think left out, sir.
Yes. Okay, I think we will. I think we will stop the session, I guess.
Yes, sir. Really wonderful, sir.
Thank you
from
so
starting
much.
from how to get the data and how to classify that. Everything is excellent, sir.
Thank you so
Really,
much.
all
Thank
the
you so much.
participants enjoyed very well.
Very. Thank you.
Okay,
Thank you
sir.
so much,
Thank you,
sir.
sir.
Thank you so much. So you do
Okay,
you
sir. By
have any
tomorrow,
information?
sharp at, sir, by tomorrow, sharp at 10:30, we will start the tomorrow session, sir. Forenoon session.
Okay, sir. Okay, sir. Okay, sir.
Okay, sir. By all the participants will get the same thing, like uh, link, attendance, PPTs, everything through mail and WhatsApp. Thank you, sir.
Thank you so much. Thank you, participants. Thank you
Thank
for
you,
your.
sir. We will end the session.
Okay, thank you.
Thank you, sir.